Good morning. Good morning. This is Mr. Henley Clement here for the shape and construction. Today is week 4. We are going to learn about shapes and construction, chapter 3. So I make this program to guide you through the whole books for 6 months. Okay, I hope that you really enjoy it. Okay, and this morning in the science year 7 science, I have a comment which is very good. Thanks for your comment, because to do this is just like I'm doing this all by myself. Okay, and to get your feedback is a motivation for me to go further. Thank you very much. Thank you for your help and your support. No matter maybe you are from comment or your like or your share, it really helps us a lot. Help me a lot. Thank you very much. Okay, today again I'm using this book. Okay, we'll be learning year 7. Okay, sometimes we'll go deeper, sometimes we'll stick to the year 7 standard. Okay, I'm doing this, and if you need further or if you need easier, always let me know and comment. Thank you very much. Okay, so we are going to learn from this book. Okay, even though it's not exactly the same, but I'll try to summarize and make it as short as possible so that you can have a brief idea of what you are going to learn in year 7. Okay, so this is Mr. Henry Clement for shapes. Okay, before the shapes, we need to learn about lines. Lines. Okay, actually, can you see this is a dot? This is one dot. Okay, many dots will make a line. Can you see? Okay, I think this one you know, right? One dot makes a line, and many lines will make a area. Will make an area. Okay, can you see the idea of that? And area, many pieces of area will make you a volume. Okay, this is the thing. Okay. Okay, so today we are going back to learn about this simple thing. Okay, I try to make it easier and understandable for you. Okay, so we have to learn line. This is straight line. Straight line means that without any curve. Okay, the next one surely will be the curved line. I think this is the first lesson in your year 1 mathematics books. Okay, and then you have ray. Ray means this is a source. This is a direction. Okay, and sometimes we have parallel rays or parallel line. Okay, parallel line, that means that they are moving towards the same direction. Okay, and angle. Angle, that means there's a two line that intersect and to build an angle here. Okay, so today we need to learn some terms for the angle. Okay, some terms for the angle. I think mostly you know already. Okay. Okay, so this is a very small one. Okay, this is less than 90 degree. Okay, this less than 90 degree or less than 1/4, less than 1/4 of the turn, full turn. So we call it a acute angle. Okay, or less than 90. Okay, and this is slightly more than 90. Okay, more than 90. So this is more than. This is in between. How to say? This is in between 1/4. Okay, and then this angle. This angle. Let's see. This is A. This is A, and then slightly larger than 1/4 turn and smaller than 1/2 turn. Okay, so this is in between 90. Okay, to 180. Okay, so we shall call it the okay, this is A, sorry. This is called obtuse angle. Okay, and this is 90 degree. Okay, 90 degree is a 1/4 turn or 90 degree, we call it a right angle. Right angle. And then we may have the straight line. Actually, I forgot about one line. We may have a straight line from here turn to here, which is 180. This is the half turn. Okay, half turn. Well, surely we have another one. Okay. Whole turn, one turn is 360 degree. Okay. So for the angle, okay, for the angle more than half. Okay, see, this is more than half turn. Okay, more than half turn, but less than whole turn. This is okay. Can you see the other side of the acute angle? This is the acute angle, but this is the other side. This is the obtuse angle. This is the other side. All this angle we are calling as a deflect. Okay, deflect angle. Okay, which is deflect. For example, this is R. This is R. R will be larger than 180 degree, but smaller than 360 degree. Okay, which is more than half turn, but less than 300 full turn. Okay, full turn. Okay, so when you have two lines, okay, we have an intersection point. Okay, intersection point. Okay, here I want to do a demonstration for you. Okay. So in these two color pencil. So if they are parallel, they won't meet until the end of the word. Okay, they will not meet. They will not meet until the end of the word. Okay, so this is so-called the parallel ray or parallel line. Okay, but when the angle slightly change a little bit, can you see? I change a little bit angle. You can see that in some time they will cross each other. So this is called intersection. Intersection. There will be a point here. So we call it a point intersection. Okay, intersection. This point is called intersection. Okay. So can you see here? Okay. So if you have this one, this parallel line, and if you have on the top of it, okay, it may become combined into one line already. Okay, but sometimes it's on the top. Okay, you see, it's not. Yeah, it's not touching it. It's still parallel. Okay, and the one thing, okay, if you have this intersection, okay, but do you think this is an intersection as well? Okay, it depends on see W, X, and Y and Z. Okay, if they are not touching, then surely there are no intersection, even though it look like a cross. Okay, so but for the moment, year 7, okay, we're only learning this one is intersection because you'll be touching one. Okay, so this is the, I think you know this one, right? Okay, this is the tools to use to measure the angle. Okay, this is so-called the name is called protractor. 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 Okay, this is the protractor with the half turn. Okay, that means that from 0 to 180, you can from left to right, or you can go to the right to the left. Which is this is clockwise. This is anti-clockwise. Okay, this is half turn. Okay, so you can use this to measure the angle. Okay, today I'm going to show you how to measure the angle. For example, there are some tricks to do this one. Okay, you need to know this one. Okay. Okay, if this is a line, which is, if this is acute angle. Okay, this is acute angle. Okay, I'm not sure you can see or not. Clement, will you help me to light? Okay. Okay, I think you can see clearly now. Okay, So to measure the angle, you can start from one line. Okay, always remember, can you see? There's a gap here, empty one. Usually you have a gap one. Okay, it's not a continuous line. Usually you have a gap here. What is the purpose of the gap here? Okay, and then you have the center here. This is the center. So this center you need to go to the angle. Okay, the point. Okay, so can you see? I'm not sure you can see or not. Oh, okay. Let me move closer. Okay, let me move closer. Okay, maybe I can. Yeah, I'm hide myself in the shadow of the thing. Okay, so you must see the line. Can you see? If the line can see, separate from the zero line, then this is not accurate. Okay, so the first thing you need to find the junction. Okay, and you can see. Okay, if they are slightly different thing here. Okay, a gap there is not a correct one. Okay, you should go until you move until the line is hidden. Just hidden. Okay, just hidden. Can you see this original pencil line is hidden? Can you see? It's just like it looks just like the line. Okay, the line from the ruler, from the protector. Okay, so then okay, see. Okay, then this line also must be hidden one. Okay, now you can read here. So this one is 30, 35, 30. Sorry, I cannot see. 36, 37. Okay, a little bit more than 37. Okay, let's say round to 37. Okay, so this one will be 35, 36, 37. So this angle will be 37. Okay, so if this is less than 180, you can always measure straight away. Measure. Okay, shouldn't be a problem. Okay, can you see? However, if you want to measure the deflect angle, this is acute angle. Deflect angle will be the other side, right? Okay. If this is for the other side, it means that you need to know the logic behind. Okay. You have two methods. The number one is you calculate, you measure this one, and then you use the calculation 360 degree minus 37 degree, then you get what is the red color, the different angle should be. Okay, then you can minus. Okay, so this one will be 3, 2, 3. No, 3, 2, 3. Okay, let's check. 360 minus 37, you get 323. Yeah, it's correct. Okay, so the other way. Okay, sometimes you may use other. You may wish to use other method. Okay, it means that you can use the additional one. Okay, so now I use the green color. So you can extend the line longer than this. Okay, if you don't want to measure the 37, you can always go for this one is 180, and then plus the small one. Okay, come. So the line should be hidden. Okay, and then you get. Wait, let me see the line. Okay, I think that's the line. Okay, 140, 41, 42, 43. So it's 143. Okay, so this one is 143. Okay, so you can add up the green color. This side and this side also can measure the whole deflect angle. It's a 180 plus 143. Okay, let's check. 180 plus 143 will give you the 323 as well. Okay. So this is a way to measure the angle. Just remember, you need to move everything until it covers the gap here. The gap. I'm not sure you can see it. Yeah, the gap. Okay. To combine as one line. Okay. So I think in year 7, all you need to do is just doing the measurement, doing the measurement. Okay. later in this class, I will be introducing 3 different types of the triangle for you. One is called equilateral. Equilateral means that all the 3 sides is the same. Okay, how to show the 3 sides the same? We have to mark here. This means that all these 3 will be the same length. Okay, sometimes in your exam, the exam paper will state that as a not to scale, and it means that if you measure, even though I said this is 6 cm, 6 cm, but when you put your ruler and measure, it may come out not as 6 cm. Okay, let's see whether I try to draw 6 cm is it correct or not. Okay, how to draw a 6 cm triangle? Okay, this is the way. Okay, so firstly you need to have some tools. Okay, so let me allow. You see, this is not sharp. Okay, we try to sharpen it. Okay. Okay, to use to draw accurately, I think I know that I think everybody can do this one. Okay, just there's some miss. Okay, number one is what about your paper? Okay, your paper. I know that most of students now they are having the table which is not the wooden one. Okay, they have some very smooth and tiles which is very glass surface. When they try to draw, okay, this sharp tip cannot stick to the table and not paper, and you keep on moving on it. Okay, so allow me to bring higher because I cannot draw. Okay, so you need to measure. Okay, you need to measure from 0 to 6. Okay, so you can either using from 0 to 6, or you can use 1 to 7. Okay, 1 minus 7, 7 minus 1 is also 6, right? Okay, so you can use to 6. Okay, okay. So this is 6. Okay, this is 6. Okay, so for some teacher would like to teach the way of using here to draw. For me, I don't think holding this plate is good because sometimes if this is not so tight, when you push this way, then the angle will change. Okay, so for me, okay, actually I will draw a line first to get the shape, the equilateral of the 6 cm. So I will draw a long line sometimes. Okay, and then after that I will measure out 6 cm. Okay, and then I will use the compass. Okay, to draw also 6 cm. Okay, this is 6 cm. I will hold this part again, and then I will only let the lead or the pencil to just slide past, without placing any pressure. Try to not to press down the paper, but you press down this part, the tip of the metal part. Okay, so you can draw a circle. Okay, a circle. Okay, see? Okay, a circle. Okay. And then again, you can draw a circle, just press down here, okay? And then the next, this one, just, okay? Okay. And then you just connect the line together to the intersection point, okay? Then this will make the equilateral triangle of the 6 cm, okay? Okay, my table is not flat. Just now you can see there's something slightly. So to practice this question, okay, I know that because I'm teaching when I'm teaching online with this syllabus, some students cannot draw. Okay, when I go to their house and visit them, okay, when I first changed my physical class online, okay, I found out that most of the students have the glass top table. Okay. So this is the way to draw an equilateral triangle. Okay, then the length should be the same. Okay, let's measure. So this is around, yeah, this is 6 cm. Okay, this is also 6 cm. I think there's a Yeah, this is also 6 cm. Okay, so to draw the equilateral triangle, you need to do this way. Okay, and then let's see the syllabus. Okay, looking at triangle. Okay, the next one is isosceles. Isosceles, you have two sides. Okay, before that, when you have this equilateral triangle, the interior angle will be 180, okay, for all three. So since they have the same size, so each one will get 60, 60, and 60. Okay. For the isosceles, it's not only look this way, okay, I can draw another isosceles for you. Okay, allow me to use the line. Okay, for example, I'm using this again, 6 cm. Okay, this is 6 cm. Okay, so I put a cross here. Okay, there's many types of the. Okay, you can draw. Okay, many type of the, how to say, many different types of the isosceles triangle from the 6 cm side. Okay, number one. Okay, I can draw down here. Okay, I can draw down. Okay, this is 6 cm, can you see? And then again, this is also 6 cm. And when I join these two, okay, this is an isosceles. Oh, sorry, you cannot see from my screen. Okay, triangle. Okay, so on the other side, if I want to make the 6 cm from here to here, okay, and then I have another one from here. Surely you think that this is smaller angle. You can see also. And then this is a larger angle. Can you see? So when I connect two lines, oh, so my table is not flat, okay, not smooth enough, okay. So this angle is look more flat also as well, okay. So, but one thing you need to know, okay, even though this is different shape, but this two angle on the foot here is the same. And then same thing happened to here. This is the same angle. For example, if this is 70, this one should be 70. If this is 15, and this will be 15. Okay. So even they look so different, okay, but they are also named as isosceles triangle. The last one is all the three sides is without equal one. They are different and different. We call it scaling. Okay, this one is a normal triangle. You can draw any triangle. Yeah, look like that. Okay. Okay, just the angle, all angle. This is 1, this is 2, this is 3. Yeah, they have the 3 different angle. Okay, but this one you have the same. This is A, and then this is A. Surely this one you know. This one is 180 minus 2A. Why minus 2A? Altogether 180 minus 1A minus 2A. You get this angle. Okay, that's the idea. Okay, then we need to learn 4 sides. That's not the 3 sides. Now we have 4 sides. We call it parallelogram. Parallelogram. Okay, so this line means that these two lines. Okay, let me change it to red color. These two red color. These two red color. Red color is parallel. Well, now green and red become the purple already. But these two is the blue color is parallel. Okay, these two are the same direction and these are the same direction. Okay, and we have the rhombi or rhombus. Okay, these two lines. Okay, this and these two lines is also parallel, and as compared to these two lines. Okay, but one thing different is this all 4 sides all four sides of this shape is same length. Okay, same length. Okay, actually this is, I think you know, this is actually a square that you press down, then you change shape. Okay, and whether this one is a rectangle, which is move sideways. Okay, this is this is the square which move sideways. Okay, so from this shape, okay, the angle is this. This angle is same as this. Okay, whereas this acute angle is same as this. Okay. The rhombi, same thing. This is same as this, and then this one is same angle. Okay, thank you for watching. Thank you for catching up with learning with us. Okay, I'm showing this one so that to motivate you. Okay, in the pandemic, okay, we can learn pretty well. Okay, and I hope that you can further your research into other books and articles and maybe video and learn more. Okay, I'm also learning. Okay, I'm also taking a extra second degree for myself. Okay, I hope that you can learn. Okay, trapezium. When I draw this one, you know that this is the parallel line. Okay, usually in mathematics we call this A and this is B. And if I give you the 90-degree part, this is the height. Okay. This is 90-degree. Okay. Both sides. And trapezium. Okay. When you duplicate another trapezium, okay, can you see? If this is trapezium, you duplicate the same one, you can have this one, the same one. And then you cut this part, and you can put here. So it become a rectangle already. Okay. So rectangle, the area of rectangle is this is length, this is W. Okay. This L is actually, this is A. Can you see A? And then this is from here B. This L. Okay. And then the width is actually is the height. Okay. So the formula for this one, okay, for the area is actually W times L, and the area also become half of the whole thing, So the W is H, the L is A plus B, okay, A plus B. But since this is two sets of the trapezium, so you need to halve it. So the formula given for area of the trapezium will be half A plus B times H, okay. Okay, let me lower down again so you can see clearly. Okay, the next shape you need to learn is kite. Kite. Kite also have two pairs of the side with the same length. Okay, but there's no parallel line. Okay, there's no parallel line for this shape. Okay. Okay. The top side, top two side will be the same length, whereas the next one will be the same length. Okay, this is the kite shapes. Okay, when you draw the diagonal line, okay, it will make a 90-degree right angle here. Okay, this may not look like a tuition, but it's just a sharing. I hope that you can catch it, and if you need further explanation, always don't hesitate. Let me know and comment. Okay, and if you think there's some part that I'm weak and need some improve, always message me, always comment, and or private message me, and always go to the Facebook or Instagram. Okay, and I plan to create a group there, but what is the form of the group? Please let me know. Okay, please let me know how should we can work together. It's not only I teach, I know that some teacher, some senior there is willing to, or some junior also, some junior also learning very well. They are willing to teach. Okay, they are willing to teach. Okay, they are willing to teach. Okay, so we may work together to find a new way out for this online learning. Okay, so the last part, we will be introducing some solid shapes. Okay, so the cube actually has all the sides with the same length one. Okay, that means there's a many square to make a cube. Okay, and then we have a cuboid. Cuboid, there's one side or two sides or three sides which is different length. So this and this will be the same, and then this one it will be the same length, and then the long one will be the same length. Okay, so this is a cuboid. Cuboid is actually a rectangle, many pieces of rectangle to make a cuboid. Okay, and you have the cylinder. You have the cylinder here. Cylinder, can you see the coin is also cylinder? Okay, as long as okay, okay, you can find the circular surface of two. Okay, and there's the one there. Can you see? Okay, as long as you can find this one. Oh, I missed out one sphere shape. Okay, okay, cylinder. Okay, so cylinder means that there's a many piece of a circular round shape, so that together to make a cylinder. Even though it's very thin or very tall one, very short one, both are called cylinder. And then we have the prism. Prism is there's a many shapes of prism. Okay, we can have this pentagonal prism, which is starting from the pentagon, and then many pieces of pentagon. Okay, you stack out together, overlap it, become a volume. This one is a triangular prism, and you can have six is called hexagonal. Okay, then you can put many pieces behind. Can you see? Then to make a prism. Okay, this is the idea of prism, and this is so called a cone. Okay, a cone. Okay, a cone can be very tall one, sharp one, and also just like what I share with cylinder, can be not very sharp one. Okay, the last one will be the pyramid. Okay, pyramid. How to name the pyramid? Okay, if the base is a triangle, so you name it as a triangular base pyramid. If this is a square, you may say this is a square base pyramid. Okay, this is how you call the name. Okay. Okay. This triangular base pyramid sometimes is called tetrahedron. No, because tetra means four side, four face. Sorry, four face. 1, 2, 3, 4. Four face. Okay. Four also four vertex. Okay. There's one more I missed out, which is a sphere. Okay. Okay. Okay, so for today's class, okay, I did not summarize these two for you. Okay, I think you can learn it from the books. Okay, which is this part. Okay, property of the solids. Okay, then you need to learn how many faces you have for the cube, how many edges and how many vertices. This is for the solid, and also the property of the, let me see, yeah, the property of the polygon. Okay, a triangle, you have the three sides of okay, a triangle, you have the three sides. Okay, so this is a triangle. Quadrilateral means four sides. Quad means four. Okay, pentagon means 5. Hexa means 6. Hepta means 7. Octa means 8. I will draw this way, 4, 4, okay, to make 8. Nano means 9, okay? Okay, and deca means 10. Okay, so this is the name of the ships. Okay, so please, okay, this one I will take a photo for this one so that you can have in the Facebook, okay, or you can just snap a screenshot, or if you don't have the books, okay. Later I will put this one in the Facebook. Okay, I hope you enjoying this class, and always let me know if you need further explanation, and if I have anything to improve, always let me know. Always let me know. Thank you very much. This is Mr. Henry Clement, okay, for your Year 7 Science and Math class. Tomorrow, Tuesday, we will have our Year 8, and Wednesday, we will have our Year 9. Okay, thank you very much.